This question is also a direct variation, a little bit different words, directly proportional to, but we know that's the same as direct variation. Okay, so blah, 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 blah. Define the two variables in this statement. So starting with the first sentence, the velocity of fluid flowing from an opening in the side of a container. I'm going to pick the traditional V for velocity of the fluid. And this is in, so I'm looking through the question. Opening is at the bottom, height of the fluid 2 meters. Fluid was coming out at a speed of 5 meters per second. So that's in meters per second. Okay, back to the first sentence. The velocity of fluid flowing from an opening in the side of the container is directly proportional to the square root of the height. I'll pick H for height of the fluid, and units in the opening was at the bottom. Height of the fluid was 2 meters, so that's in meters. State a variation statement using the variables. So back to the first sentence, the velocity flowing from an opening inside of a container is directly proportional to fish square root of the height. All right, find the equation. So that's simply replacing the fish symbol with an equals, throwing in a constant, and then we're going to sub in our numbers and find out what the constant is. So the numbers said the height of the fluid above the opening was 2. So square root 2. Okay. And the fluid was coming out at a speed of 5. All right, we're going to take that square root 2 and move it to the other side. Right now it's attached by multiplication. So on the calculator, we're going to divide, moving the multiplication to the other side, opposite. So on the calculator, 5 divided by square root 2. And I'm getting a big long decimal, 3.5355. So you get to choose how to round this off. I'm going to choose 2 decimal places. So I'm going to make this 3.54. There's no units on the K. Well, there are actually units on the K, but we're not going to want that in our equation. We're simply going to leave this at 3.54. And the equation, so we're not done yet, we have to write down the equation, is V equals 3.54 square root H. So all the equation is leaving the variables there and subbing in the K number. Now, using your equation, find the speed of the fluid. So find the speed of the fluid coming out of the opening when the height of fluid above the opening is 7.6. So 3.54 square root. And the height, so that would be the H, is 7.6. So on my calculator, 3.54 times square root 7.6. And again, I'm getting a big long decimal. And I'm going to round this off to 2 decimal places again. So 9.759. So 9.76. And the velocity is in meters per second. Graph the equation, label the axis using a table of values. So a table of values. And the dependent variable, so that's sort of like the y, velocity, And the independent variable is the height, sort of like x. So in our first setup, we had the height was 2 and the velocity was 5. In our second setup, we had the height was 7.6 and the velocity was 9.76. Okay, graphing this. The dependent variable, the first one mentioned, was velocity. So that goes on the up and down axis. And the independent variable, the second one mentioned, is h. So looking at our h numbers, we've got a 2 and a 5. I don't want to make this too squished, so I think I'm going to go every other line. So this would be 1, 2, 3, 4, 5. And this is 3 and 1. And for our v numbers, we go from 5 up to 9.76. No wrinkles allowed, by the way. So let's see how many lines we've got. This is 2, 4, 6, 8, 10, 12. I think I'm going to go by ones. So this would be 2, 4, 6, 8, 10. Okay, now for the dots on the graph. The first one is going to be going across 2 and up 5. 2 and up 5. The second one is going to be across 7.6. Whoa, didn't go far enough. 7, 9. Across 7.6. So this is 7.6 about in there. And up 9.76. So down here. Now this is a square root graph. Square root graph, same, so a root graph, same as a power graph, it's always going to go through the 0, 0. So I'm connecting the dots, and again, like the power graph, it's going to be a curved line. So something like that. What is the dependent variable? The dependent variable is the one mentioned first. So it said the velocity of fluid depends on. So the very first variable, velocity of fluid, what's the dependent variable? V.